Very happy to be joined today by Justin Talon and Piotr Gawlowicz from SRS, two of our earliest collaborators and truly our partners in crime from the early days of CELEOS. The team at SRS played a key role in helping us validate and mature the product, and they continue to drive it forward in real field-driven use cases. With that, Piotr, Justin, thank you very much for joining us, for being part of this very first edition of Orbit Stories. I'll kick it off with the first question. So SRS has been a pioneer in pushing both terrestrial network and non-terrestrial network solutions, from building full protocol stacks to advanced testbeds. Could you tell us a bit about what your team is currently working on in the NTN space and how perhaps CELEOS fits into that workflow?
Sure, yeah. So yeah, we've been interested in non-terrestrial cellular use cases for a long time. We've been working on different air-to-ground use cases and doing LTE prototyping over LEO satellites. So NTN was nothing new for us when the 3GPP started to standardize it. And now, especially with the standardization, it's a key product for us. So we're working on a number of publicly funded projects related to like 5G NTN, from national ones in Spain to ESA ones and EU SNSJU projects as well. In terms of how like CELEOS fits into that, I mean, we do much of our protocol testing in emulated environments, and we developed our own internal tools to do this. But CELEOS was great to give us this step up into RF and allow us to do that final RF verification to work in real time, which gives an extra hardening to the product. So it's been really great from that perspective for us.
Thank you for that. Piotr, anything to add?
Yeah, exactly. So the main point was here to put our tests in the real RF environment, and then before we used to test over some emulated environment, just passing samples between two processes over some 0MQ sockets, but now we are able to test with the real hard radio devices, and that was very good in order to discover some real-time issues of our stack and also like propagator.
Understood. By the way, you guys mentioned as well that you picked up quite easily, the sort of passing from TN to NTN. So you are well known for, going for these new technologies early and testing the boundaries. Thinking back, what do you remember from your earliest experience with the satellite channel emulator CELEOS? Maybe even back when it was still rough around the edges a bit.
Yeah. So I first came across CELEOS and you guys at MWC. I think it was not 2 years ago, and I was at the NTN summit. I was talking to Frank Zeppenfeld from the ESA, and he had nice things to say about you guys, and he recommended I go check out your demo. Yeah, that's what I did. I was over. I was talking to your engineers and to the guys from Fraunhofer you're working with, who I've also known for a while. And yeah, I was really impressed with what I saw, and it kind of piqued my interest because I'd been in the market for something emulator wise, but I was still surveying the market and kind of running up against price barriers in other solutions. So I was very interested, and then it was great to get chatting to you guys, and then we kind of planned a first interaction based on that chat.
I guess even back then you were trying to look at certain aspects which came down to your testing and development activities. You have been well known to have this core strength in testing, both terrestrial and non-terrestrial. What kind of testing did CELEOS enable you to do, and perhaps without which it would have been perhaps a little bit more difficult, not so easy?
So yeah, I guess it's like, as I said, it was the ability to bring it into the RF environment and be able to test in real time in the real kind of RF-based channel impairments. It adds an extra level of complexity to developing any stack, of course, and also like being able to benchmark against another person's interpretation of like the orbital models that are involved in creating these kind of solutions. Like, because like when you're testing against your own emulated environment, you're creating the impairment and the compensation. So there could be mistakes you're making on both sides, right? So you need to verify against someone else's interpretation of these models. So like being able to see this, our solution work over a third-party emulator like this really gave us this peace of mind that we were interpreting the standard and the orbital equations in the right way.
Yes, exactly. So maybe I can add something here. So especially in NTN, since the satellites are moving very fast, and then the UE has to pre-compensate the transmissions, like meaning like it has to keep the delay constant between the round-trip time constant on the entire link, and also has to pre-compensate the Doppler effects before the transmissions. So here it's very important to have very accurate testing, because even like some small residual delay in order of microseconds can collapse the entire link. Yeah, so it's very important for us to test with third-party components, so that we are closer to let's say real operation.
Understood. Well, I guess that being said, there must have been a lot of collaboration between yourselves and the team. So I know that this has happened quite in several stages. In those improvement cycles where your input influenced CELEOS, do you have any particular examples that maybe stand out on, you know, how this improvement happened over the this time of our back and forth?
Yeah, sure. So like the kind of major roadblock we faced when we first started using the CELEOS channel emulator was like how we kind of, our team versus your team, how we like interpreted creating an orbital model based on TLE. So this is something that's I guess in some way open to interpretation about the best course of action to take. But we kind of realized when we were inputting the TLE data, which like defines an orbital model, and running the test, that your emulator was working by taking the epoch time of the TLE as just the current time and running it forward based on that, whereas our interpretation had been to compare the epoch time to the actual UTC time being read from our computer and fast forward the model to like the current actual time on the system and run the pass on that basis. So once we realized that we had this kind of mismatch in our interpretation of how to derive the model from the TLE, we were able to interact with the engineers on your side and describe to them how we wanted it to happen versus what was happening now. And once we kind of had a mutual understanding of the discrepancy, the engineers in Lasting were able to give us a new model, or a new binary of the software, and work with us to kind of converge on a usage. And once we did that, we were able to get the LEO scenario working perfectly, and it was great. It was great to have that interaction with your engineers, because it ultimately gave us a working system.
Understood. You know, you guys have been always tracking this sort of next steps, both in terrestrial networks and non-terrestrial network evolution, both from standards to implementation. What are the most things that you look forward to in the upcoming CELEOS releases, or related in general to technologies?
So one thing I'm looking forward to taking advantage of with the CELEOS is the fact that you can set up the orbital impairments based on channel characteristics that are independent of the real actual or configurations that you're using. So to give a concrete example, we can use like FR1 frequencies, like 800 megahertz, the regular cellular frequencies, on our actual RF devices, our SDRs, but we can set up channel impairments based on any RF configuration that we choose. So what this gives us the ability is to test FR2 protocols and impairments, but without having to have FR2 equipment or converters or anything like that, because these kind of equipments, you probably know, are extremely expensive. Yeah. And are only really used for like very narrow use cases for deploying FR2 at Ka band. But if we want to test our solutions for those frequencies, previously we had to consider like Ka band, Ku band emulators as well as up converters, whereas now we can simply run at FR1 and apply FR2 impairments to our link and test these much more challenging FR2 environments with the like Dopplers in the megahertz, the phase noise that is associated with these kind of higher frequencies. So that's something that we haven't done yet, but like as FR2 becomes a kind of crystallized in our roadmap, we're starting to implement it even for the terrestrial case. We're going to start thinking about this in NTN and certainly going to be utilizing this feature in CELEOS to verify it from an NTN perspective.
Keeping that in mind, and also the fact that the activity that you do over at SRS is used a lot of times as a reference point within the community, basically, who wants to learn from your experience. What are the things that they should consider in order to adopt CELEOS? What would be the pluses for adopting CELEOS?
Killer point for me was the kind of engineer interaction that's available with working with CELEOS. I mean, it's something that anyone who's worked with, like, commercial grade RF testing equipment from like the large vendors knows that there's a world of bureaucracy between you and anyone who can really actually help you from a technical perspective if you're having problems, and this more hands-on relationship with products that are so technical like this is invaluable, and it just makes it so much more usable and kind of friendly to, especially to like a small organization like us. And yeah, it's just and the usability in general, even as a product, user friendly and quite flexible, and even with the DeFi capabilities, it allows users who maybe don't have the more expensive even like RF equipment to even deploy it on. They can utilize it as a software product, which is something that could be very valuable for even like student users or people who don't have a large like RF lab, So that's something that would be a real advantage.
So taking all this into account, if you would need to or had to sum up your experience with CELEOS in just one sentence, what would it be?
Cost effective and flexible.
I am going to quote you on that. All right. Look, I think from the perspective of the question answer part of this session, we are done. If you would like to add some finishing words or finishing ideas to this whole experience, activity that you have had.
I guess, yeah, we're just looking forward to strengthening our relationship and seeing our two products appear beside each other in kind of bigger venues.
But, well, we are prepping the next release, and I guess you are going to be first off. I'm already checking this with the guys that you're going to test the very next release that we're going to have available by the end of the year. So that being said, looking forward as well to see you guys soon, I guess, live somewhere in the States in March, I guess. But up until that point, I think we're going to have a lot of exchanges in the following period. So that being said, thanks very much for both of you and for your insights and joining us for this session of Orbit Stories. And thank you very much overall for the valuable feedback that you guys have provided since the very beginning of CELEOS. I think it has been crucial for us to arrive at this stage of the product where we are today. So for that one, it's always a big thanks going out to you guys. Looking forward to writing the next chapter together with you, and I guess until next time.